Communication. We usually don't pay enough attention to it. It's easy to overlook how complex it can be. If you have ever written any software that communicates over the network, you're likely very familiar with frameworks like REST, SOAP, or RPC. gRPC provides an alternative communication framework that's practical, efficient, scalable, and secure. It's a great tool to have when you have service-oriented architecture or microservices. Let's see how it works. gRPC is an open source framework developed by Google to connect their microservice infrastructure. Compared to text-encoded REST or SOAP services, gRPC is more efficient in terms of bandwidth and CPU, thanks to using a binary format encoding and using HTTP2 for transport. HTTP2 is a more efficient transport method because it can multiplex several messages in the same session. In addition, gRPC supports bidirectional streaming. It's language agnostic and it's extendable, with a plugin system offering things like authentication, load balancing, and retries. gRPC is a general-purpose RPC framework. It's designed to connect the large number of microservices running within and across Google's data centers. In this way, it serves as a replacement for other RPC frameworks like JSON RPC or XML RPC. An important caveat for gRPC is that it's not supported in the browser, so it's not viable for the web frontend. It is, however, a valid alternative for mobile and IoT applications. At the heart of gRPC is protocol buffers, or Protobuf. Protobuf is to gRPC what JSON is to REST and XML is to SOAP. It is a binary format to serialize structured data so it can be efficiently stored on disk or sent over the network. Protobuf is language agnostic and platform neutral, strongly typed and defined with a special interface definition language, allowing us to write the definition once and reuse it everywhere. This counts both for data structures, messages, and service definition. Before we can implement gRPC, we need to define two things, at least two types of messages, one for the request and one for the response, and one RPC service. We do this using the protobuf syntax. Let's create one now. We'll do the mandatory hello world example. Create a file called hello-world.proto. We'll start by setting the syntax version to 3. This is the latest. We need a package name. This is the namespace in which everything lives. Next, we define the request message the client sends. It contains a field called name. Then we define the response message from the server containing a field called message. And we tie everything together with the greeter service. This is the RPC endpoint. We'll call it say hello. Now, say hello takes a hello request message and answers with a hello reply message. There are two things to note here. First, each field has a type and a name. Second, the field has a unique integer number. It's called the field number or the field tag. Protobuf relies on this number to identify the field while decoding the message. This means that each field must have a unique number within the message. So, for example, if we want to add more field to this message, we would need to increment the integer number like this. We should never reuse field number. Doing so will mess up the decoding since the number is the only thing that identifies the field. So whenever we need to change, delete, or create a new field, we must use a new integer number. To be safe, we can declare used numbers with the reserved keyword. Once we do this, these numbers cannot be used ever again. We can move on to the server code. To run the server, we'll need a couple of dependencies we can install with npm. Let's create a file called server.js. We'll start by loading the gRPC modules and defining the path to the hello world.proto. Then we load this file with package loader as a package into the server. We'll use this later. Now let's define the response function. It only replies hello plus the name in the request. Finally, we can define the serve function. We'll create a server, a gRPC server, and add the services. We'll add the hello world greet service that we defined, we loaded as a package. And then we bind the server to this port. This is the default port for gRPC. We define this connection as insecure because we are not using a certificate. Otherwise, we would need to create or get a certificate to add into the server. And finally, we start the server. One way to quickly test the server is with gRPC curl. This is a tool like curl but for gRPC endpoints. Once installed, I can run grpcurl slash plain text to disable TLS slash proto to pass the proto file. Then we add the API endpoint and the fully qualified name for the method call. Notice I got hello undefined. To fix this, I can send data with /d. Now we get the proper response. I can also get information about the protocol with the list and describe commands. With the server working, we can move on to the client. Let's create a file called client.js. We'll start by defining the path to the proto file, and then we'll load the dependencies. Same as the server, we load the proto file with a proto loader. This gives us a package, and we are ready to create the request function. This takes the server address and the name we're going to provide with the request. We create the client. The client is a method in our package, in our Protobuf package, and we pass the server address, and we tell the client this is an insecure connection without certificates. And then we invoke, say hello, passing the name, and log the server response. Finally, we call the request function. Now I can run the client on a separate terminal, and that's it. We have a fully functioning client and server. Earlier, I said that Protobuf is language agnostic. This means we can reuse the same proto file for different languages and frameworks without modification. To support this feature, Google released a tool called protoc. It takes the proto file as an input and generates code in different languages, both for the client, the server, for the API endpoints, for the messages. There are several languages supported out of the box, and there are more languages added via plugins. For example, let's say I want to implement the same server in Ruby. First, I need to install protoc, and then the gRPC gems for Ruby. Then I can create the Ruby code for the message classes and the gRPC connection with. This creates two files, hello world _pb.rb and hello world _services _pb.rb. Those are Ruby files we can use in our Ruby project to communicate and access the request data and the response data and the API endpoint. With this tool, you can take one proto file and generate tabs for different languages. This is great, for example, when you have a monorepo and you're building a microservice architecture. The first thing you are likely to notice while using gRPC is that it's less intuitive than REST, mainly from the fact that communication is binary, so more work is required to communicate with the gRPC API. But there's a reason Google uses gRPC internally. It's much more scalable and suitable for messages for up to a few megabytes. It supports streaming, and it's a better tool for most use cases than REST or SOAP. Are you using gRPC? What is your preferred method for communication? You can also leave a comment and suggest topics for me to cover next. I'm going to leave links in the description to blog posts that go deeper into gRPC and cover other languages and frameworks. Thank you for watching, and if you like this video, consider giving us a like and subscribing. See you on the next one.